Hello everyone, welcome to our channel Physics for AP. So today we will be doing an experiment on Prism by Mr. Kunal Mehta, and we will find out the refraction index of the prism by using the formula and a graph.
Experiment from the prism, and we are also going to measure the angle of deviation from the prism. And for this experiment you require a prism. Here we are using typically a prism whose angle of prism is 60 degree, equilateral prism, and protector, scale, few softboard pins, eraser and pencil. So let's begin with the experiment, and this experiment will be almost the same as the refraction through glass slab experiment. So what do we need to do is, first of all, take two softboard pins and fix it on the wooden pad. So this is A4 size paper on the wooden pad, and now I am fixing both the softboard pins over here on two edges so that my paper, A4 size paper, does not move. Now these softboard pins, put it aside, the all rest 4 softboard pins you would be requiring. Now what am I going to do is, I am going to put this prism over here, and then I am going to mark the outlines. Okay, so here we have made the outline. Pardon me. Now we are going to make an incident ray, and the incident ray, say for example I wish to make the angle of incidence is 60 degree. I choose this point to be the point of incidence. So this part of the protector, I need to put it over here. Angle of incidence 60 degree. So we know that the normal would be 90 degree. So this is 90 degree. So 10, 20, 30, 40, 50, 60. So the 60 degree would be over here. We are not measuring the angle from here, otherwise it would be 30 degree. We are measuring the angle from 90 degree to 30 degree. That's why it is 60 degree. Mark a point on 90 degree as well. Now this would be your normal, and this would be the angle of incidence, right? Okay. Now two pins you are supposed to fix it over here on the incident ray. Now put the prism back over here at its marked position. Now you are supposed to see these two pins from this side. They will be visible to you. And now I'll be seeing the pin, these two pins from this side, because this is the incident ray, that would be the refracted ray, and the emergent ray would be somewhere over here. So I need to see the pins from here. And you need to see it very carefully with one eye closed to avoid the parallax error. So let me do it, and afterwards what you are going to do is, when you see these two pins over here, we have another two pins which we are going to put it on this side, and we'll make sure that these two pins are in straight line arrangement with these two pins. So okay, so now these two pins, when I was looking at these two pins from this side, because this is the emergent ray which is coming to my eye, so I would be seeing these two pins in this line, and now these two pins I have attached in such a way that all these 4 pins are visible in a straight line. Let's see it. So if you watch these two pins, these two green colored pins are visible over here, right? And now if you see that all four pins are appearing in a straight line. You guys are lucky because you can see the spectrum band of 7 colors at the back side. So you can see very carefully all four pins are placed in a straight line, and quite spectrum is visible on the top part. You can see that there is a spectrum, so dispersion is also seen over here, right? Okay. Now what we are going to do is, now we are going to mark these two places. So I am going to remove these pins. Now we'll put the prism aside. Now no need of these pins also. These 2 points join with a straight line over here. This will be your emergent ray, and from here the normal is at an angle of 90 degree. So this will be the angle of emergence, this is the angle of incidence. Now I am going to join these 2 points, and this would be my refracted ray. Incident ray, refracted ray. Now you can see that it is, instead of going straight, it is bending towards normal due to the refraction. Now our main task is to find the angle of deviation. We know that this angle is 60 degree, right, angle of prism. Now I am going to extend the incident ray forward, and I am going to extend the emergent ray backwards. So I get this angle, that is called angle of deviation. So let's measure with the help of a protractor. Okay, how do you measure this? See, make sure that this point is falling over here, so like this, and the angle of deviation, this line matching with this line, and the angle of deviation is just over 40 degrees. It is approximately 42 degrees. So the angle of deviation for the prism is 42 degrees, right? And I kept the angle of incidence as 60 degree. If you just want to measure the angle of incidence, I had kept it 60 degree. So when I kept this angle 60 degree, I got the angle of deviation is this. Let me measure the angle of emergence as well. So angle of emergence with respect to the normal, 10 degree, 20 degree, 30 degree, 40 degree. You can see that from here 90 degree, this is 10, 20, 30. Now I am mistaken, it is, yeah, it is the same only, 40, no, 35, sorry, because this is, these are the gap of 5. So this angle is 35 degree, right? So this was the experiment about the dispersion, sorry, the refraction through prism. Hopefully you have understood this.
So from the experiment which you have seen before, so here we have the prism where the refracted ray is not parallel to the base here. So here we have the angle I1, which is the angle of incidence, which is making with the normal to the PQ surface, and here we have an angle I2, which is called the angle of emergence, and which is making an angle of I2 with the normal n dash to the peak or surface. And here we have an equilateral triangle which is making an angle A. So equilateral triangle means, so we take it as angle 60 degrees over here. And here we have the refracted angle, that is R1 and R2 on both sides. So here the refracted ray, as it is not parallel to the QR, so in this case I1 and I2 will not be same, so they will be different in them. And here when we extend the incident ray and the emergent ray, here we get an angle which is called the angle of deviation. So we denote it as small d, or can denote it as delta 2. So small d is nothing but the angle of deviation. So how much angle it has been deviated. So for example, this is the incident ray. So for how much angle it has been deviate, that angle of deviation is we call as D. And now when coming to the, and when we increase the angle I1, so when we go on increasing the angle over here at a particular angle of incidence, here we will get the refracted ray parallel to the QR. So the refracted ray which is inside the prism will be parallel to the QR. At this situation, here the angle of incidence will be equal to the angle of emergence, and the deviation which we get here is called the angle of minimum deviation. So it is called as the angle of minimum deviation. So angle of minimum deviation, so it is represented with the letter capital D or delta M, that means minimum deviation. So in this case, when we plot a graph between them, so when we plot a graph, so the x-axis and this is the y-axis. So in x-axis we take the angle of incidence I1, and in y-axis we take the angle of emergence I2, and when we draw a graph between them, so we get a curve shape. So we get a curve shape. So at a particular curve, that is at this point where we get the maximum curve, and this point is said to be called as the angle of minimum deviation. So at minimum deviation, that means at this point the angle of incidence will be equal to the angle of emergence, and that curved point is called as the angle of minimum deviation, that is capital D. So we draw the graph taking as I1 as x-axis. So here why we have to take the I1 as x-axis but not I2? Why? Because so the values which we known will be taken as the x-axis. Like here the angle which we are inserting, so is it 30 or 40 or 50 or 60, that all the values that we are taking. So the known values will be taken on the x-axis. The value which is to be find it out, that is we measure it after doing the experiment, we measure it, so that will be taken in the y-axis, and we plot a graph, we get a curve at a perfect curve, that at the bottom of the curve. So at a particular point we get the angle of incidence is equals to angle of emergence, and that is said to be called as the angle of minimum deviation, capital D. And we have a formula to find out the angle of minimum deviation, that is to find out the refractive index of the prism, that is n is equals to sine of a plus d by 2 whole divided by sine of a by 2. So this is the formula where we use to find the refractive index of the prism. So by using the formula n equals to sine of a plus d by 2 by sine a by 2, we can find out the refractive index of the prism. So actually how we get this is from the formula n equals to sine I by sine r. So in this case I is equals to a plus d by 2, and here r is equals to a by 2. And if we modify this little bit, so we get the value 2i is equals to a plus d. From this d is equals to 2i minus a. So this is the formula for the minimum deviation, that is if you want to find out the minimum deviation over here, so we have the formula d is equals to 2i minus a, which is the minimum deviation over here. Is it clear? So this is how we find out the refractive index of the prism over here. So where a is called the angle of the prism, and where capital D is called the angle of minimum deviation over here. And if we see a numerical over here, like we have a refractive index, we have the angle of prism as 60 degrees, the angle of minimum deviation will be taken as 30 degrees. So you have to find out the refractive index of the prism. So we have to find out the refractive index of the prism by using the formula n equals to sine of a plus d by 2 whole divided by sine a by 2. So if you substitute those values, sine of a 60 plus d 30 by 2 whole divided by sine a, that is 60 by 2. So that is sine 90 by 2 by sine 30. So sine 90 by 2 is nothing but 45. So sine 45 value is 1 by root 2, 1 by square root of 2, by sine 30 value is 1 by 2. So as it gets reciprocal into 2, so 1 by root 2 into 2. So 2 can be written as, again if we modify it, we can write it as root 2 into root 2. Why? Because root 2 whole square can be written as 2, right? So that means root 2 into root 2 can be written as 2. So root 2 into root 2 by square root of 2. So we get the answer overall value as root 2, that is 1.414. So that is the refractive index of the prism for this given problem here. So we can find out this type of numericals by using this formula, or otherwise if they tell you to find out the angle of minimum deviation, so we use the formula D equals to 2I minus EA. So this is all the overall experiment to find out the refractive index of the prism by using this experiment, and make sure that the refractive index should be parallel to the base of the prism, then you will get the minimum deviation. So by using this minimum deviation, you can find out the refractive index of the prism. So thank you for watching the video. Please subscribe the channel, click the like button if you like it, and give your valuable comment. Thank you everyone.